Hello everyone and welcome back. So before I start today's lecture, I am going to provide you with the solution to the problems that I have given to you in the previous lecture. The first question was you were given a graph and you were asked to find out the adjacency and incidence matrices of that graph. So let us first find out the adjacency matrix. Here we can see that the graph G has order 5. So Ng is equal to 5. That indicates the adjacency matrix is going to be a 5 cross 5 square symmetric matrix. Now let us fill up the entries of this matrix. As you can see, I have already created here a 5 cross 5 matrix and the rows and columns are labeled by the vertex names. So the very first entry is corresponding to the vertex u with u. Now there is no loop at the vertex u, that indicates there is no edge between u and u, so it is 0. You can see there is only one edge between u and v, so this entry is 1. Between the vertices u and w there is no edge, and similarly no edge between u and x and no edge between u and y. Now since adjacency matrix is a symmetric matrix, so the moment I have obtained the first row, I can immediately fill up the first column also. So it will be 1, 0, 0, 0. Now there is no loop at the vertex v, so this entry is 0. There is one edge between the vertices v and w, so this is 1. Between v and x, there are two edges present in the graph, so this entry is 2. Between the vertices v and y, there is no edge, and immediately I can fill up the second column. There is no loop at the vertex w, so this entry is 0. Between w and x, there is one edge, and between w and y, there is no edge. No loop at the vertex x, so this is 0. Between the vertices x and y, there is only one edge, and there is no loop at the vertex y. So this is the adjacency matrix of the given graph. Now let us find out the incidence matrix. As the graph has 5 vertices and 6 edges, so the incidence matrix is going to be a 5 cross 6 matrix, where the rows will be labelled by the names of the vertices and the columns will be labelled by the names of the edges. Now let us fill the entries. We will fill this matrix column by column. So corresponding to the very first column for edge E1, we can see in the graph, E1 has n vertices u and v. So accordingly, under the column E1, I will put 1 for the row corresponding to u and the row corresponding to the vertex v, those which are the endpoints of the edge E1, and the rest entries will be 0. For the next column, that is corresponding to the edge E2, it has n vertices v and w. So under the column of E2, v and w will have entries 1 and the remaining will have entries 0. For E3, the n vertices are w and x, so 0, 0, 1, 1, 0. E4 has n vertices x and y, so 0, 0, 0, 1, 1. The edge E5 has n vertices v and x, so 0, 1, 0, 1, 0. And finally the edge E6 also has the n vertices v and x, same as E5, so we will have 0, 1, 0, 1, 0. This is the incidence matrix of the given graph. Now in today's lecture, I am going to present to you some special types of graphs which are basically known by some names, particular names. For example, one particular graph we have already discussed in our lecture, that is the Peterson graph, that I am not showing in this particular lecture again. We have discussed that particular graph, how it is drawn. So like that, there are some other typical name graphs that you should know. So let's start with the simplest one, that is the triangle. And that is our very known graph K3, the complete graph K3, and it is drawn like this. So this graph is named as triangle. Then we have the claw graph, which is drawn in this manner. Now when you come across a name graph, you can think of all the properties that we have discussed until now. For example, you can find out the adjacency incidence matrix of the claw graph. You can find the maximum, maximal cliques, independent sets, etc. Now in the claw graph, if we make the bottom two vertices adjacent, then it becomes the paw graph. So this is the graph paw. Next we have the kite graph, which is basically a C4 with one diagonal. This is the house graph and it quite looks like a house as well. So you can easily remember it by the name. Next we have the bull graph and it looks roughly like a bull head. So that's how you can remember it. The next one is the bow tie graph, and as the name suggests, it looks like a bow tie. The next one is the dart graph. The dart graph can be easily drawn from the kite graph that you can relate. So these are some particular name graphs that I have mentioned in today's lecture. These will be really helpful when you will get questions like find the maximal click of the bull graph. So you should know how the bull graph looks like. Or for example, you are asked to find the adjacency matrix of the dart graph. So you should have an idea how is it drawn so that you can answer that question. So some typical standard name graphs should be known to you. So these are some particular types of graphs. So today's lecture is only based on this. I'm going to meet you again soon in the next lecture of the series. Till then, if you have any doubts, you can mention in the comment section below. And if you love learning with me, then please do like, share and subscribe to our channel. Till then, thanks for watching. Take care and bye-bye.